All right, here we go. So the first thing I want to do today is go through all the problems in the first exam and answer any questions that you might have. And then when we finish that, I'll start describing the next topic, which is functions. That's right here. You can see lab 4 is focused on functions. So half of you have already started on that from the previous lab, but, so it'll be a bit of a review perhaps for them. All right, so let's go ahead and take a look at the exam. Let's go over the exam so we make sure we understand. If you missed these problems, then now's another opportunity to figure out how to do them. Okay. All right, let's look at this. This code right here. Is this a good idea? You want to go through the exam?
Yeah.
Yeah. Okay. Now these problems will appear again on the final. So you're going to see these again. So you've got to make sure you know how to do these. All right, so when this code runs in figure 1, what does it output to the console? All right, and I'm just glancing over it really quickly there. I see there's only one variable I have to keep track of. That's good. It's one variable, I. Initialize it to 3. So look, there's two statements at the top level here. The first statement that runs is this one. And when that statement completes, then the second statement runs, which is this one right here. That's a statement in itself. That's the second statement. And that statement has substatements, which are repeated whenever the loop condition evaluates to true. As soon as the loop condition evaluates to false, the statement has finished executing. All right, so let's go through this. And maybe I'll copy this here. So we have one variable I to keep track of. We initialize it to 3. That's done in this first line. And we go into the loop. So the loop condition, it's possible that we don't execute the body of the loop at all. If the loop condition starts as false, then we're finished with the loop. But the loop condition is true because 3 is less than 32. So what we're going to do is we're going to compute this value and then print it. And then we'll print a space. So the next value we print has some room from the previous value. So I minus 1, well, I is 3. So we're going to print 2. And once again, that doesn't modify I. We're just using I there. We're not modifying I. And the second statement that we execute is here. This is an assignment to I. So we take 2 times I. So we read from I. This is like reading from the memory labeled by I. Read from that memory, which is 3, and multiplying by 2 to get 6. And that 6 is then assigned to I through that assignment operator. So now I becomes 6. That's it. We don't print 6 or anything like that. Okay. And then the next thing we do is the loop condition. I is still less than 32. That's true. So we compute I minus 1, which is now 6 minus 1, so that's 5. We print 5. And we print a space as well. So we've now finished this statement. Now we'll go to the next statement. Here we modify I. We read from I, multiply by 2, and then write into I the result. So I is 5. I'm sorry, I is not 5. I'm getting confused, see? That's how you can make a mistake, right? I is actually 6. So one of the things you've got to be clear about as you're going through this problem, you need to make sure that the output is separated from the value, the state of I. So don't mix those two together. And look at the way I'm keeping track of it here with these notes. That helps me keep those two things distinguished from each other. So we need to compute this. and I is 6, not 5. We're not confused. We printed 5. So now we have to use I. That's something different to what we printed. Now 2 times 6 is a 12, and then we assign that into I. And now we've finished this last line in the loop. This is not a for loop. In a for loop, we do the end of loop operation. In a while loop, there is no end of loop operation. It's just the last operation we did inside the body of the loop. That's the last, that would be the end of loop operation, I guess. So we evaluate the loop condition. I less than 32, that's true, because I is 12. And we compute I minus 1, that's 11. We print 11, but I remains 12. We go to the next line where we assign I. 2 times I, 2 times 12 is 24. Assign that to I, so we have 24. Go back to the loop condition, 24 is less than 32. Let's print 24 minus 1. We're going to print 23. And then we assign 2 times 24 to I, so now I becomes 48. We go to the loop condition. The loop condition is false. That means the loop is finished. The loop statement is completed. We go to the next statement, but there is no next statement, so we're done. This is the output. All right, let's look at the next one. When the code in figure 2 runs, what does it print to the console, or what does it print? Let's see that. So we have 2 variables, n and k. We could keep track of them like this. So we have 3 statements to evaluate. We complete the first statement, the second, and then the third. And then we see what we've done. The first statement is to assign 5 to n. The second statement creates a k and assigns something to it. We see here we have n plus plus and plus plus n, so we have to remember the difference between those two. N plus plus, when the plus plus follows the variable, it means it's delayed. That increment operation is done after reading from n. So here we need to read from n in order to compute n times 2. So we read n as 5 and multiply by 2 to get 10. So what I have highlighted here is 10. 10 is assigned into k. And then after having read and used n, we increment n. So n becomes 6. So we've just completed the second line, second statement. Now let's do the third statement. And here we have a pre-increment as opposed to post-increment. The pre-increment we just do right away. It has very high priority, high precedence, not priority, I guess you call it precedence, more term that's used. So right off the bat, we don't read n and use n. We need to increment n first. So let's increment n to 7. And then n times 2 is a 14 plus k, that becomes 17, and we output 17. There we go. Suppose that h is an integer variable. Did I get that wrong?
It's actually 24.
I thought I got something wrong. n times 2 is 14.
And then plus 10 is 24.
I'm sorry, 14 plus 10 is 24. Did I get it right?
Yeah.
Oh. Yeah, I would have got a B on the test. Thank you. Suppose that h is an integer variable. Write code that prints high when h is greater than 6. and low when h is less than or equal to 6. All right, so h is an integer variable, so I'm giving it to you. You don't have to create it. You don't have to define it. Just use it. If h is greater than 6, then print high. Else print low. And that should be that high. So that's a compact way to write it. You see, when h is greater than 6 is the opposite of being less than or equal to 6. So I can use an else condition just like that. All right, what about 4? When the code in figure 3 runs, what does it print? All right, what does this code print?
472.
472? How do you get there, though?
230 times 2 plus 10 plus 2.
Say it again.
230 times 2 plus 10 plus 2.
Good. 230 times 2 plus 10 plus 2. Well, you did a lot in that calculation, right? So let me break it out and explain each of those steps, exactly how to do it. So you have to notice here, well, there's obviously a k and an n. A k is 230, n is 10. Good, that's done. Now I have the loop. And if you look at the loop, you see that k is not modified in the loop. So this upper bound for the loop is fixed at 230. And we see that it's strictly less than 230. So I is strictly less than 230 in the loop condition. I starts at 0. I is incremented in the end of loop operation. And when I hits 230, we're done with the loop. So when I is at 230, it does not run that statement. Okay? When I is 230, this does not run. It runs when I is 229. It runs when I is 0, 1, all the way up to 229. In other words, the loop runs 230 times. Okay. So what does it do 230 times when it runs? It adds 2 to n. It adds 2 230 times. That's the same as adding 2 times 230, which is 460. So we're increasing n by 460 of what we started at 10. So when we're done the loop, n must be at 470. And here we're going to print, we're not going to print 470, we're going to print 470 plus 2. So we're going to print 472. Any questions about that process? Okay. What about 5? When the code in figure 4 runs, what does it print? Well, these are all very similar. So what does this print? Well, I'm just glancing at it. The first thing I notice is that the output statement is outside of the loop. It follows the loop. So we're only going to print one number once. There's 3 statements. First statement, which creates an I, assigns 6 to I. Then there's a loop that does something. And then we output I. 1, 2, 3. You can see that this is on the outside of the loop because the loop is closed here. That's the closing brace for the loop. And then we emphasize that it's outside the loop by not indenting this line. This line is indented to emphasize that it is a substatement of the loop statement. The cout statement is not a substatement, so it is not indented. So let's walk through it mentally after making those observations. We create an I and assign 6 to I. And now we enter this loop. And the first thing we do there is check the loop condition. I less than or equal to 606. Well, I is 6. Well, we've got to keep track of I. I'll put it right there. And the output we'll put down here. And there's no other variable, it's just I. So I is 6. And 6 is less than or equal to 606. So what we'll do there is compute 6 plus 300, 306, and assign to I. So I becomes 306. I'll do it like this. I started at 6 and now it's 306. And now we do the loop condition. The loop condition is true. Oh, we don't output anything. We just do this one assignment in the substatement section. So you add 300 to I. Now it's a little tricky. We have to be careful here. Is the loop condition true or is it false?
True.
It's true because we have less than or equal to. I is less than or equal to 606. That's true. Once again, we don't output anything yet. So we add 300 to I again. And then we have 906. And after we do that, we check the loop condition. The loop condition is now false. And so we get to the third statement in this little program. And we print I. And since I is 906, that's what we print. There we go. So let's look at the next one. So here's another program we need to analyze. What does this print? Well, I is 5 and it's an integer. J is 2, it's an integer. X is 5, but it's a double. So it's a floating point value. Double precision floating point number. So I divided by j, because I and j are both integers, the division is integer division. So 5 divided by 2 is 2.5, but we've got to toss out the half. So we only get a 2. So we're going to print a 2. And in the next line, the numerator x is a floating point number. So the compiler interprets the slash as floating point division. So we retain the decimal value, the fractional component of the number. So that's also 5 divided by 2. So we're going to get 2.5. Sorry, that's that one. What about 7? When the code in figure 6 runs, what does it print? These are all very similar, aren't they? There's so many of these that are just like this. Once again, we have 3 statements in this little program. This is the first statement, this is the second statement, and this is the third statement. In the third statement, we're going to print something, so we're only printing one number.
904.
Huh?
904.
900?
904.
904. That's good. But now how do we get there?
300 times 3 plus 4.
300 times 3 plus 4, that's right. The loop runs exactly 300 times. And I'm not going to go into those details, but now you should know when you see this, you should say, right away, you should say, we're repeating the body of the loop 300 times. So we're starting at 0. The key things to look at is starting at 0, and this value that we're incrementing, k, is we're going up by 1 with this end of loop operation here, and then we're strictly less than some limit here. So the limit is the number of times that we do run the loop. So this loop runs exactly 300 times. We're adding 303s to I. We're adding 900 to I starts at 4. So we're going to print 904. All right, what about write code that prints 3,000 random integers that are something. I'm going to show you how I focus on how to break the problem into pieces rather than just seeing the whole thing in detail. Write code that prints 300,000 something. See? I know right off the bat I need a loop that runs 3,000 times. And that's something that you've got to practice and you've got to memorize. There's a loop that runs 3,000 times. We need to print something 3,000 times. See, I don't know what the something is yet. You know, that's a fuzzy thing. Now let's go back and focus on that part, and we can forget about the 3,000 part now. We need random integers that are less than 100. Random integers less than 100. So we're going to print. So we use this. That's how we print, right? And the rand function generates a random integer. But the integers need to be less than 1,000. So the standard trick, is you just use the modulo operator. And that gives us values that are less than 100. And greater than 0, and I didn't mention that. All right, what about, suppose n is an integer greater than 1, here's number 9. N is an integer greater than 1. Write code that determines whether n is prime. Program should print prime when n is prime and not prime when n is not prime. So we have an n. So if n is prime, then we print prime. Otherwise, you print not prime. All right, so we looked at this this code. N is prime if there doesn't exist any integer between 2 and n minus 1, including 2 and n minus 1. If we don't find an integer other than 1 and n that evenly divides into n. So we need a loop. We start at 2, and that should be I. So we want a loop that has the value range between 2 and n minus 1. And the trick here is that we're just looking for a divisor. When we find a divisor, we'll print not prime. But if we finish the loop and we don't find a divisor, that's where we print prime. So if we finish the loop and we don't find a divisor, we'll print prime. So in the loop, if we find a divisor, in other words, if n divided by, or mod, if n mod I is 0. In other words, if I take n divide I and I get a remainder of 0, it means I evenly divides n, right? That's the test for divisibility. If n mod I is 0, then we're going to print not prime. And then we can return. That's the shortest way I can think to do it. If you wanted to do it using a Boolean variable, you could do it that way as well. Let me show you the other way. We assume it's true. This is the alternate solution. Alternate, is that right? It's an alternative solution. Is that right? Alternate? That's not the right word, is it? Alternate. That's how people they say alternate solution. Is that what people say? Alternate solution. It's not the right word, is it? Here I am. I'm in precision mode, right? Because I'm giving a lecture, so I got to think really carefully and use my words exactly right. Okay. So is prime is set to true, and if we find a divisor, we'll set is prime to false, and then at the end, if I'm just going to take this line up here. If n is prime, so if is prime is true, then C out prime, else C out not prime. There we go, we're done. We can break that up if we want. Put that on the next line. Maybe that's hard to read, so I'm going to do it like this. Make it easier. We don't, the braces are optional here, but actually it's a good idea to put them in because otherwise you can, the common bug is to add another line in there and to forget that you didn't have braces. You just indented, and the line is not actually, the line doesn't become a substatement. It's just because you're not using braces. So a lot of people just use braces all the time. So this is another way to do it. Declare an is prime variable, and so on. But this is equivalent. So that was the hardest problem on the exam, that one right there. Unless you want to...
There's a way to do that same thing, just an if and else, without a bool or for.
What's that?
Is there a way to do that problem with just an if else statement without a bool or a for?
No, was it without a for? For loop?
A Boolean.
This is how you do it without, huh?
Without a Boolean function and a for. Either of them. Just
No, you have to have one or the, you have to use a loop.
yeah.
You can't get around this loop. And this is how to do it without a bool. And here, when you use a bool, you still have to have the loop. But here we have to get out. We need to skip over this, see? You have to skip over that line. We can't hit this line. That's why I have a return statement here. But in our code, in our bigger piece of code that we're writing inside of, if we can't do a return here, then we're going to need to use a Boolean variable like this. So you got to have a loop on that one. All right, what about Show the Unix command to list the contents of your current folder. Well, that was the easy one. That's just ls right there. Show the Unix command to change the current directory to a folder in your current directory named SAM. So just cd SAM. That's how to change a directory from your current folder to a subfolder named SAM. 12. Suppose that you have a file named main.cpp that is in a folder named lab1. Suppose that lab1 is in your current directory. Show the Unix command to delete main.cpp. So rm is the remove command, a delete command. The folder is lab1, and there's a main.cpp inside of it. That's how you get rid of it. So the slash is follows the folder name. This folder names are on the left-hand side. The file inside of it is on the right-hand side. And as people seem to get those mixed up for some reason on this problem, I don't know why. Show the Unix command to change your current directory to the parent folder. That's cd ... That's how to go to the current folder. Extra credit. Suppose that n is an integer greater than 1. Write code that prints the prime factors of n. So, you know, I never give extra credit in this first exam ever. I can't remember. But it just came to me. I was writing the exam, and I thought I would throw it in there just for those students who really grasp this one. You know, I'm gonna give you extra credit. I wasn't expecting anybody to get this, but a couple of you did, so that's great. So if n is some number, how do we print all of its prime factors? And we went through this in lecture, and it was one of your lab assignments. So we need a loop, and we're going to keep shrinking n. I think it's greater than 1, but we'll see. So we need to declare an integer, say k, that we're going to divide into n. So if n is given to us, we don't need to declare that. So if n mod k is 0, that means k is a divisor for n. In that case, we're going to print k. We got a divisor. And we're going to reduce n by k. And if k is not a divisor, let's go to the next k. Now let me think about this condition here. Now I got to check this. Is this right? N greater than 1. Let's suppose that n is 3. And if n mod 3 is 0, that's false. Then increment k, so k becomes 3. N is greater than 1. If 3 mod 3 is 0, it's true. Then we print 3. And then we take 3 divided by 3, and we get 1. And then we exit the loop. What about 2? It's the same thing, right? I think that's all right. So there we go. It's not a lot of code, is it? I just wanted to, for those who really got the algorithm, really clicked in your head, you would have been able to write this out because it's not a big program. It's just a matter of having grasped the algorithm. It's not even a matter of memorizing it. It's a matter of appreciating it. Like if it clicked for you, you know, if it's like, ah, yeah, aha, yeah, that's how it works. And then it's not a matter of like memorizing the code. Oh, I got to put a semicolon here. I got to have an else statement there. That's not how to do it. It's going to be just like, oh, I get it. The light bulb goes off. And, you know, and it's not something, you know, for some people it's immediate, maybe because they're natural at this, and others they have to work at it before you really get the concept. You know, so it's not necessarily easy. I'm making it sound easy, but it could be tough. But you still have a light bulb going off. You get it at some point. It's like, yeah, that's it. And then you can reproduce the code. You don't have to remember else and, you know, plus, all that stuff. You've got to grasp the algorithm of it. Anyway, that's the exam. Any questions? All right. Let's talk about functions. And you know what? I'm gonna break the video up into for those people who want to skip over this part.